பார்க்க போகிற டாபிக் என்ன பார்த்தீங்கன்னா மேத்தமெட்டிக்கல் ஃபிசிக்ஸில் வந்து டென்சார் என்ற டாப்பிக்கில் ஒரு சிம்பிள் ப்ராப்ளம் பார்க்கலாம். ஷோ தட் எவ்ரி டென்சார் ஆஃப் ரேங்க் 2 that is second rank can be resolved into symmetric and anti-symmetric parts. ஸோ இந்த மாதிரி ஒரு கேள்வி கேட்டால் எப்படி ஆன்சர் பண்ணலாம்? சொல்யூஷன். So suppose I take any tensor of rank 2, let us say A I J. Okay, so both of them I have taken as a contravariant tensor. Don't worry whether I will take contravariant or covariant, doesn't matter, or mixed tensor, that is also doesn't matter. So what we will do is we will take at least any of these type. Let us say contravariant tensor of rank 2. Now this can be resolved. So this is tensor of contravariant tensor of rank 2. Okay, rank 2 because there are two indices. So this can be resolved as, so I can write this as half times 2 times Aij. So just multiply and dividing by 2. Now this can be written as half times Aij plus Aij, because I have just expanded this, so 2 times, right? So this is written like this. So now what I am going to do is I am just going to add a tensor which is Aji, and I am going to subtract the same whatever I have added, so minus Aji plus Aij. So now combining these two, so this and this, so we are going to write this as half Aij plus Aji plus half Aij minus Aji. This part, let us define this quantity as maybe Bij, and this quantity we call it as Cij. Now what about Bij? Bij is 1 by 2 Aij plus Aji. This is actually a symmetric tensor of rank 2. Okay, let us see why this is called symmetric tensor of rank 2. So Bij we take like this, 1 by 2 Aij plus Aji. Just interchange the indices. Okay, so now it becomes Bji, which is equal to 1 by 2 Aji, because wherever you see I, replace by j, wherever you see j, you replace by I. So this becomes Aij, which is same as Bij. So therefore Bij is a symmetric tensor of rank 2. Now let us take the next one, Cij. The Cij, which is equal to 1 by 2 Aij minus Aji. So we will do the same thing. I is j replaced by j, so Cji, which is equal to 1 by 2 Aji minus Aij, which is equal to, when I take minus outside, minus half Aij minus Aji, which is equal to minus Cij. So this implies Cij is an anti-symmetric. Another name for anti-symmetric is skew-symmetric tensor of rank 2. So what is the conclusion? So the conclusion is any tensor of rank 2, so this is any tensor of rank 2 now can be decomposed into a symmetric tensor of rank 2 and anti-symmetric tensor of rank 2. So this is the conclusion, that is any tensor of rank 2 can be decomposed into symmetric tensor of rank 2 and anti-symmetric tensor of rank 2. So this is a idea behind this problem. Okay, so now let us try to highlight the formula, which is very important, which is often asked in gate questions, that is number of independent components. One for symmetric tensor, another for anti-symmetric or skew-symmetric tensor. If the dimension is n dimension, then the number of independent component is 1 by 2 n into n plus 1. For this case, anti-symmetric tensors, the number of independent component is 1 by 2 n into n minus 1. So this is the formula, which is often very important. Let us do some one or two gate questions based on this topic. The first problem is, consider an anti-symmetric tensor Pij with indices I and j running from 1 to 5. The number of independent components of the tensor is, so this is anti-symmetric tensor. Okay, so therefore see, for anti-symmetric tensor, the number of independent component is 1 by 2 n into n minus 1, and the dimension is, so n goes to 5, so therefore it's a direct substitution, 1 by 2 5 into 5 minus 1, that is 4, so 2, so 5 into 2 is 10. So answer B, this is the correct answer. So this is another problem. It is asked in GATE 2012. The number of independent components of the symmetric tensor Aij with indices Ij is equal to 1, 2, 3 is. So now they asked to calculate the number of independent components for symmetric tensor. So we know that formula is 1 by 2 n into n plus 1. So n is, here it is 3, it's a 3 dimension, right? So n is 3, which means the number of independent component is half into 3 plus 1, it is 4. So 2 gets cancelled. So answer is 6. C is the correct answer. Thanks for watching this video.